Okay guys, I just wanted to cover a tiny bit more. So I think we finished the class talking about acceleration, and you guys probably know, since velocity and acceleration are similar, just like velocity, and we talked about how it can be instantaneous or it can be average velocity, the same is true for acceleration. So when the time interval is large, the acceleration is the average acceleration. And when the time interval is infinitely small, the acceleration is instantaneous, okay? But remember the kinds of graphs for velocity on a position versus time curve. The slope of that graph is the velocity. On a velocity versus time curve, the slope of that graph is going to be your acceleration. Okay, so know that. Okay, I also want to show you guys or work through with you guys on your own problem 1.11, 1.11, and 1.12, 1.12. Okay, it says, during what time intervals is the object speed increasing? And this is a velocity versus time graph, okay? So the slope on a velocity versus time graph is going to be your acceleration. All right, so remember that an object is speeding up whenever the velocity and the acceleration have the same sign, right? So from about 6 seconds to almost 12, like 11.8 seconds, you can see that the velocity is positive and the acceleration is positive, the slope is positive. Okay, so that is one section in which the object is speeding up, or the speed's increasing. But that's not the only one, okay? If you look at from 16 to 20, right there, you can see that the velocity and the acceleration are both going to be negative. They're both going to have the same sign. So therefore, the object is speeding up then as well, even though they're negative. So the time intervals in which the object is speeding up, yours might be slightly different than mine because we're reading on a graph, is approximately 6 to 11.8 seconds. And then on the end, it's going to be 16 to 20 seconds, okay? Now on your own, 1.12 asks, when is the object's acceleration 0? Okay, well, I already talked about with this kind of graph that the slope is the acceleration. So the acceleration is going to be 0 whenever the curve is flat. And there's two places which that happens. I would say it's at 6 seconds, right there, you can see. And then it's also going to be at 11.8 seconds, that same measurement I got right there, okay? So that's the answers. Those are the answers for the on your own problem. All right, another thing that your book talks about is they talk about on this kind of graph, on a velocity versus time graph, that the area under the curve represents the object's displacement. We don't really have in this class a way to measure that, and we're not going to be talking about it, but that is something that when you get to calculus, you calculate slopes and areas under curves. Okay, so that's something that you could explore in that. And then in class, we wrapped up very quickly about this, but we just did the on your own problem, and we found out that our object in that problem, it had 0 acceleration at 6 seconds and about 11.8 seconds. But during those two times, the velocities were not 0. Okay, so although the acceleration was 0, the velocity was not. And that's a very, very important concept that you need to remember from this module, okay? If velocity is 0, acceleration doesn't have to be 0, and vice versa. If acceleration is 0, velocity does not have to be 0, okay? That's gonna be super important moving into module 2. So hopefully this has been a little bit helpful. Please read over, look over the module before you take your test, and you will bring your test to class with you, and make sure to follow the syllabus, and I'll see you on Monday. Okay guys, I wanted to go over the review questions for module 1 with you. So I have them listed right here. Number 1 says, What is the main difference between a scalar quantity and a vector quantity? Like we talked about in class, remember a vector quantity has information about direction while a scalar does not, okay? Number 2, on a physics test, the first question asked the students to calculate the acceleration of an object under certain conditions. 2 students answer this question with the same number, but the first student's answer is positive, while the second student's answer is negative. The teacher says they both got the problem 100% correct. How is this possible? We talked about this, right? So they defined their directions in the opposite way, and that's how they're both correct. Number 3, which is a vector quantity, speed or velocity? That would be velocity. Number 4, what is the main difference between instantaneous and average velocity? Remember, average velocity is measured over a finite time interval, while instantaneous uses an infinitesimally small time interval, right? So that's the difference. Number 5, what physical quantity is represented by the slope of a position versus time graph? You need to know this, that's velocity. Number 6, what do physicists mean when they say that velocity is relative? The velocity an observer sees depends on the velocity of that observer, and that's what they mean. Sorry about the noise in the background. My daughter's learning to play clarinet. Okay, number 7. You are reading through someone else's laboratory notebook and you notice a number written down, 12.3 meters per second squared. Even though it's not labeled, you should immediately be able to tell what physical quantity the experimenter measured. What is it? We should know right away because of units, that's acceleration. Number 8. Another experiment in the same lab notebook says that an object has a 1.4 meter per second squared acceleration when it has a negative 12.6 meter per second velocity. At that instant in time, is the object speeding up or slowing down? Well, the acceleration is opposite of the velocity. They have opposite signs, is what I mean by that. One's positive, one's negative, so you know that it's slowing down, okay? Number 9, what kinds of graphs do you study if you're interested in learning about acceleration? That is going to be velocity versus time graphs, okay? The acceleration tells us how velocity changes with time. So if you're interested in learning about acceleration, you would look at velocity versus time graphs. Number 10, an object's velocity is 0. Does this mean its acceleration is 0? Why or why not? No, it doesn't. Acceleration is the change in velocity. Say velocity is 0 for a moment and not 0 the next. The velocity has still changed and the acceleration can't be 0, okay? Those are all the answers to the review questions.